The third type of chemical reactions to discuss is redox reactions or oxidation reduction reactions, or as we said before, electron transfer reactions. An example for that is combustion reactions. When you burn a piece of magnesium in air, what happens is that magnesium will combine with oxygen to make magnesium oxide. But you can clearly see that magnesium will change from a zero oxidation state in the element to a 2 plus oxidation state or charge in the compound. That means it lost 2 electrons. And on the other hand, oxygen is going to change from zero charge or zero oxidation state in the molecule to a 2 minus oxidation state in the compound, which means it gained 2 electrons. So what happened is that 2 electrons were lost from magnesium and gained or transferred to oxygen. Losing electrons, like in case of magnesium, is called an oxidation half reaction. Any substance that loses electrons is getting oxidized. Gaining an electron, like in the case of oxygen, is called a reduction reaction. If we add up these two half reactions, we will see that the left-hand side is going to be 2 magnesium plus an oxygen plus 4 electrons. And the right-hand side is going to be 2 magnesium 2 plus ions and 2 oxygen 2 minus ions plus 4 electrons. You can cross out from the left-hand side and the right-hand side of the equation to get the total equation that describes a reaction as 2 magnesium combining with an oxygen to make 2 magnesium oxide product. If you put a piece of an active metal like zinc into a copper solution, which is much less active, what will happen is that zinc will get oxidized, losing 2 electrons that will be gained by copper ions in solution, which will then convert into copper atoms and deposit as this red metallic precipitate in solution. So at the end of the reaction, all the zinc will be oxidized to zinc ions soluble in solution, and all the copper ions will be deposited as elemental copper. Same thing when you put copper metal in a solution of silver. Silver is much less active than copper. So copper in this case is going to get oxidized to make copper ions that will get released in solution, giving it that blue color, while the 2 electrons will be gained by silver, which will then be deposited into metallic silver precipitate. And at the end, solution will contain copper ions, and all the silver ions will precipitate as silver metal. So we need to differentiate between the two processes that takes place mutually in a redox reaction, which is reduction versus oxidation. Oxidation is losing electrons. So when zinc atoms convert into zinc 2 plus ions and lose 2 electrons, that's a loss of electrons. And on the other hand, copper ions will gain 2 electrons and convert into copper atoms. So for the first half reaction, zinc is losing electrons, which means zinc is a reducing agent. It gives off electrons, while copper is gaining electrons, which means copper is an oxidizing agent. Zinc is being oxidized, copper is being reduced. A very helpful concept that helps us identify oxidation or reduction parts in the reaction is following oxidation numbers, which basically are the charges that atoms would have in a molecule or a compound if electrons will completely transferred. We have a couple of rules when deciding oxidation numbers. First rule is that free elements in an uncombined state will have oxidation number of 0, whether it's an atomic element or a molecular element like O2, N2, or H2 still has an oxidation number of 0. Second rule is that monoatomic ions, oxidation number is equal to the charge on the ion. For lithium plus, it means that it has +1 oxidation state. Iron 3 plus has a 3 plus oxidation state. Oxygen 2 minus has 2 minus oxidation state. And third rule is that the oxidation number of oxygen is usually -2, except in peroxide, where it is actually -1 for one oxygen, because it exists as O2 2 minus, so each oxygen atom is going to be -1. The oxidation number of hydrogen is usually +1, except when it's bonded to metals. In this case, it's going to be -1. Group 1 is always +1, group 2 is always +2, and fluorine is always -1. The sum of oxidation number of all atoms in a molecule or an ion has to equal the charge on that molecule or ion. And finally, oxidation numbers are usually integers, but they do not have to be integers. In some cases, they will have a -1/2, for example, in case of a superoxide ion. So for example, cesium is a group 1 ion, which means it has a +1 oxidation number, and we have 2 of that, so it's going to be ×2, which means it's +2. And since the molecule is an overall neutral molecule, it has to add up to a negative charge on the sulfur that will cancel out to make an overall 0 charge on the molecule. So sulfur has to be -2 in this case in order to make the whole molecule 0 charge. Potassium nitrate. Potassium is group 1, so it's +1. Oxygen is -2, but we have 3 of that. So we have here -6 for the 3 oxygen. Those has to add up with a number to make the whole compound neutral. That number here clearly has to be +5 for the nitrogen. For the last example, the charge has to add up to a -2, which is the overall charge of the ion. And we know that oxygen is -2 times 7 atoms that we have in the formula. That makes the chromium contribution has to be a positive number that adds up to that negative contribution from oxygen to make it overall -2. So it has to add up to a +12, so that it adds to the -14 from oxygen to an overall charge of 2- for the ion. So that means it should be 2 times +6 for each chromium atom.